So we're still looking at solving with our solving systems of equations with substitution. So we're still substituting. But our essential question on this one is we're going to look at the different types of answers that we can get, because we know we can get 3 different types of solutions. So we're going to be able to identify the 3 different types of solutions. So as we go ahead and look at this first example, okay, first of all, in order to solve using substitution on this first one, we need to rewrite the equation. Okay, I need to find which letter has a coefficient of 1. Well, this letter does, the letter X in the first equation. And I'm going to change that to plus and negative. Okay, but we want to get that X all by itself. We want it to say X equals. So how do we do that? We need to rewrite this. So how do I get the 2y to the other side? I'm going to subtract the entire term. Whatever I do to one side, I do to the other. So we're left with a negative 1x on the right-hand side. This is 0, cancels out. And I have a 2 take away 2y. We probably want to go ahead and change that to plus and negative as well. Now we want x to be by itself, and we have a negative sign with it. So the opposite of a negative 1 times x would be divide both sides by negative 1, and we need to divide everything. So what am I doing? I am getting the x all by itself so I can substitute and solve. So I would have a negative 2 plus 2y equals the letter x. Now that I have that, I'm going to box this in, and I'm going to plug it into my x in my other equation. We had to rewrite that, so we got the letter x all by itself. So here we go. When we substitute here, we have 23 equals 5y minus 4, and then in parentheses, negative 2 plus 2y, close parentheses. We want to change this minus 4 to plus a negative. We don't want to lose any negative symbols here. And we want to get ready. We drew our line down our equal sign. We changed all subtraction to addition. Now let's go ahead and distribute. So my negative 4 is going to go to my negative 2, which is going to become a positive 8. My negative 4 times a positive 2y is going to be a negative 8y. And remember, we need to make sure we bring down our 5y in front and our 23. Our next step here is ask yourself, do you have like terms? My 5y and my negative 8y, I can add those together. I can combine them. They're like terms, which gets me a negative 3y. Bring down your plus 8 and your 23 on the left-hand side. We need to isolate the letter y, get it all by itself. So I'm going to go ahead and subtract 8. Whatever I do to one side, I do to the other. So I have a negative 3y equals 15. The inverse of times multiplying by a negative 3 would be to divide by negative 3. We're isolating the letter y. And we get 1y equals negative 5. We have a value for y. So that means this is going to be a 1 solution because we have one answer. Remember, a 1 solution is when you have an x and a y. We have a y. It's negative 5. So we just need to substitute into one of our original problems. I always use the original. And we need to figure out what x is. So I'm going to go back to this original problem I'll start with the yellow star. I'm going to write 2 equals 2. I'm going to plug in -5 and then minus my 1x or minus x. So we need to get the x all by itself. 2 equals -10 minus x. I'm going to add 10 to both sides. So I get 12 equals a -x. Remember, this is a -1x. The inverse would be to divide both sides. And we get that x is equal to a -12. So this is a one solution answer where our two equations graphed will cross at the point -12, -5. There was a lot going on in that problem. We had to rewrite the problem, then we had to substitute, then we had to substitute again, and we found the ordered pair. This is what we call a one solution, one point that they cross at. Let's go ahead and look at, we have two more examples. That we did first was an equation where you have one solution answer. 3 different types of solutions. And what they look like when you're solving them using substitution. That's it. So example 2 here, it does say x equals. That makes it so much easier. When it's already written with one of your variables, just saying x equals. So I'm going to box in what x equals, and we're going to plug that into our other equation. Substituting. So we have 3.5 times -2y plus 4 in parentheses, plus 7y equals 14. I'm going to draw my line. I'm going to go ahead and apply the distributive property here. So I get a -7y plus 3.5 times 4 is 14 plus 7y equals 14. We need to combine our like terms. -7y and +7y cancels out. They're gone. There's no letters left. So you just need to ask yourselves, is this a true statement? Does 14 equal 14? Yes. So since it is true, this is what we call infinitely many solutions. These are actually the exact same equations. They are equal. If you were to graph them, they are literally stacked on top of each other. They're the exact same line. You'd graph the same line twice. Infinitely many solutions. So we have what we can either have one solution where they cross at one point. We can have infinitely many solutions where they're just the exact same equation, even though they look different. They're the exact same thing. Or let's look at our very last kind of solution. I have y equals 3x minus 11. I'm going to go ahead and plug that in for y in my other equation. So I have 3x minus 11 equals -13 plus 3x. Let's draw our line down the equal sign. We want to get our x's together. I'm going to go ahead and subtract 3x. When I do that on both sides, what ends up happening is my x's are gone. 3x minus 3x is 0, and 3x minus 3x is 0. So on the left-hand side, I have -11, and on the right-hand side, I have -13, and is that a true statement? No, not true. So what does that mean? That means this is a no solution. What does a no solution mean? Well, let's think about our graph. If we're thinking of it as a visual here. This means we have two lines that when they are graphed, they are parallel lines, which means they will never cross. There will not be any points that make these two equations true. So there's 3 different types of solutions. We have no solution, the last example. We have all solutions where they're the exact same equations, or your